Broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and thanks for joining us today. I'm Harry Urban, publisher of Woodworking Network and FDMC Magazine. I want to welcome you to our webinar, Best CNC Practices in the Modern Wood Shop, sponsored by CIM-TECH. We have two presenters today. First, we have Kenny Belfato, the National Sales Manager for CIM-TECH. Say hello, Kenny.
Hello, everybody. Thanks for joining.
Kenny's been involved in CAD/CAM training, execution, development, and support for more than 30 years. He's worked with dozens of manufacturing companies from around the country for a variety of industries. He's a wealth of knowledge, so I encourage you to ask Kenny a lot of questions because he knows what's going on. Also working with Kenny this afternoon is Giovanni Ramos. Say hello, Giovanni.
Hey, everybody. Happy Thursday.
Hey, so Giovanni's been with CIM-TECH for 2 years, and his background is in technical sales. And I'm going to turn it over to Kenny and Giovanni in a moment. Just a little housekeeping. This webinar will be recorded so that you can view it again and again and share it with a colleague. There's also a couple of handouts attached on your viewer console that you can download at any time while you're on this session. And this is going to be a very interactive session. We have some polling questions that we'll push out to you as we go through the presentation, and we'll share the results with you in real time. And I can't stress it enough. We encourage you to ask questions. We'll do our best to answer questions at the end of this presentation, and the folks at CIM-TECH will get back to you ASAP after the webinar if they cannot answer your question online live here. So with that, I'm going to turn it over to Kenny Belfato. Take it away, Kenny.
Hello, everybody. Thanks again for joining the webinar. Today, I'm going to show you some features in the CIM-TECH software. It's known as Router Sim, and our company name is CIM-TECH. We've been out since 1986, and it's a long-standing program with features specifically for woodworking machines. You know, we realized early on your ability to program your machine is a very important feature there. We linked in with AutoCAD early on, and we've got an integrated system. That's what the CIM stands for, Computer Integrated Manufacturing. So the CAD and the CAM are integrated. And you'll see some features here today we're going to talk about. Today, we're going to focus on a couple specific features and items of interest. One of them is how to effectively program multiple CNC machines in your shop. A lot of times you may have machines from different vendors that have different machine configurations with, for example, different number of spindles, different number of tools in the tool changers, different gang drills. Some may be routers, some may be point-to-points, different machine origins for each router, and even the material may be different in X and Y. So we're going to take a look at that. We're also going to talk about the best way to handle small parts. We know that's a big problem for a lot of you, having parts move on the machine. We've got a lot of different strategies to help you keep your parts from moving and how to handle those small parts at the router. And we're also going to talk about controlling the flow of parts. What that means is, you know, how do I get the best yield? How can I mix jobs together? And how do I identify parts, for example, with labels? So those are going to be some of the items. And then after we talk about these items, we'll have a question and answer session. And at any time, you could start typing questions in the chat box there, and we'll get to questions. If not during the webinar, then afterwards, we'll be able to contact you directly for these questions as well.
Alrighty, now before we get into the first problem and common situation that we deal with, we have our first poll question. How many times do you have to program an individual part to prepare it for nested-based manufacturing? 1, 2, 3, or more? And we'll go ahead and give everybody a couple seconds to put their votes in.
Okay. Thank you for answering those questions. It looks like we got some good answers there. So we know you have these different machines and you may need to program them with for different outputs to each router. So here you could see, you know, I want to take a job and run it to machine number 1 or machine number 2 or 3, and I have to output different types of NC code for each one of these machines. The solution we have in our new version here is something called multi-post. What this lets you do is take any single job and check some boxes to have the job run through different configurations or different machine configurations. And you could choose different settings that you want to use as well. So not just the job settings, but material settings and variables in the post processor. And what that's going to do is output that same job to multiple machines at one time. And you'll get the results for multiple machines. So here's how that works with our RouterSim 2021 automation suite. We have a setting where you're going to place a folder. You make a folder, and we call it the multi-post folder. In that folder, we're going to put what's called a pack and go for each of your jobs in that folder. Now that's going to give you all the configuration settings, the machine origin, the NC code file extension, for example, the material information. All that is saved inside what we call a pack and go that has all your job settings in there. So once those are set up, you have your folder set, you have your different machine configurations, you could take any job and just right click on it and pick set multi-post options. Here we're going to pick 3 different machines in this list. We've got post processors for every kind of router there. So I'm just giving you an example showing 3 different machines that are running. And in reality, it's going to actually run 4 different machines because the job had its original configuration and then the 3 additional multi-post configurations. So you'll actually get, in this case, 4 different outputs when you run the job. We'll get standard NC code output, and then they'll show examples for outputting to a Bucelato and to an SCM and to a Wiki. But we also, of course, support all the different machines, whether it's an Ons, Root, a Thermwood, Northwood, Comos, you name it, we've got the posts for it. It can write the posts. So this multi-post feature is something that will save you time because it takes the same job and runs it through all those different configurations for you.
Well, Kenny, based on what you're saying, it sounds like this can save me a lot of steps when having to juggle work on different machines and all that comes with having to program different machines throughout the day. Another problem that we sometimes run into with programming our CNCs is how to handle small parts on the machine. So the next question I have is, in handling and holding small parts in a nest, how do we get around this issue now? But before we get into that, we have our next poll question. What machining tactics do you use to hold small parts? Onion skin parts, tabbing, multiple passes, different feed rates or tools, or other? And we're going to give everybody a few seconds to put in their answers.
Okay, thank you for answering those questions on small part hold down. So we know this is an issue because, you know, the parts are held with vacuum in many cases. And there's only so much vacuum to go around. And when you have these little parts, there's just not enough to suck them down to the table. A traditional method that's used is called onion skin, where you go almost through the part in one pass, and then a second pass cuts it all the way through. So the theory there is that you're only cutting a little bit on the second pass. It's less likely to put pressure on the part to move. Here's our helical motion, and it shows an onion skin where the tool ramps in along the contour of the part, cuts around the shape at one level, slides down to the second level, and then cuts that all the way through, has an overlap. And the lead out sneaks out, again, along the contour of the shape, so you're not pushing the tool back on the part to move it in any way. This onion skinning is very popular. It's like the most common way to do it. It's a powerful way to hold parts, but you're cutting around the part twice. There's a better way to do that, and we've invented this feature called Tab It Cut Start, which lets you either put in a distance for a tab or a percentage. So for example, if I put in 40%, I can cut around the part 1.4 times or 1.5, 1.6. Anything less than 2 times around the part is going to reduce your cycle time, right? And over the course of the day, that can really add up. And then the week and the month, you can get hours worth of extra machining out of this. So especially if you do a lot of small parts. Here you'll see the tool lead in and right away make a tab, and it's a ramped tab, so it ramps up and then ramps down. It's 40% of the perimeter, and it cuts around, then it overlap, cuts the tab off, and again, it sneaks out the way it came in. And here's some other examples to hold small parts. We've got many different ways to do it. So that tab at cut start is just one way. Another way may be to allow an extra bridge around the part. So small parts can have a cutter bridge, and you could define what is a small part based on a couple different settings. In RouterSim, you have an area tolerance for small parts. So anything that's 60 square inches or less, or 3 inches in X and Y, it's called a small part. And you can even define an extra small part. So that would be 30 square inches or less, or 1.5 inches in X or Y. So you have 2 levels for small parts, and that gives you different strategies. So the smalls can have a tab, and the extra smalls can use an onion skin, okay? Or you could just have them in a lower rank number. So the extra smalls get cut first when you have the most amount of vacuum, and then the smalls are second when you still have a lot of vacuum. Then the larger parts will be last. So you could define 2 levels of small parts. And then the other one there is called cutter bridge, that allows you to put in a halo around the part so that there's room, there's some meat for the tabs to hold on to. Now, a lot of machines have a lip around them that's not very useful for vacuum. So I have a small part edge allowance of 2 inches. In this case, you'll see like a yellow rectangle, and all the small parts are staying inside of that yellow rectangle because I don't have a lot of vacuum around the edge of the router like that. So small parts can stay away from the edge by that 2 inches, but large parts can go right up against it. You can even define a drawing that represents the vacuum zones on your table so that you can have small parts avoid certain areas. So it can actually be an AutoCAD drawing of your table with the zones laid out where you want your small parts to be, and they can avoid areas where there's low vacuum. That's what you're seeing there is the cutter bridge for the small parts. You got a bigger space so that their tabs will hold on to something, and they're staying away from the edge by 2 inches. Then in the next example here, we're actually going to draw a tool path to use that tab at cut start. So this is interactive RouterSim. You're in AutoCAD, and you can activate it as a button pick right inside your AutoCAD session. And we are using AutoCAD 2021 now. We're just starting to ship our 2021 version. And here is the helical motion. We've got different types of tool entry. That helical is going to give you the best cutter life and the best tool life because it's not putting pressure on the spindle bearings. There's a total depth tab at the cut start, and a negative decimal means a percentage. So it's going to be 40% of the perimeter at the tab at the cut start. So this one will lead in, make that tab. It's, again, the ramped tab, so it ramps up and down. Instead of lifting straight up and straight down, which can cause a burn mark on your part, it's a ramping motion, and that's going to be nice and smooth at your router, generate arcs wherever possible. So here it's just erasing a tool path, using AutoCAD's erase, change it to 25%, and now we'll get a smaller tab. It's 1 1/4 times around the part. Has the same effect as the onion skin cutting around twice, but you really only need to go 1 1/4 times, saving you 75% of a tool path.
Huh. So pretty awesome stuff. Thank you, Kenny, for going over some of the issues when it comes to handling small parts. And these solutions sound like plenty of great ways to handle them effectively day to day. Another problem that we have in working with our CNCs, though, whether it's small parts or multiple machines, is controlling the flow of the parts from the nest. So the next question for me is, How do we work around this now, and what else can be done about it? Before we get into that, we have our next poll question. In nested-based manufacturing, how do you control the order in which the parts are nested on the sheets? Do not control and let the operator sort out the parts manually by only processing one set of parts job at a time, manually by having the CNC programmer lay out the parts, or automatic with a scheduling system to create unique parts. And we'll give everybody a few seconds to go ahead and put their answers in for this one.
Okay, thank you for those poll answers. We know that controlling the flow of parts from a nest is important, and we have features specifically for these. For example, if I want to run these two jobs, I want to run them. If I run them individually, I don't get the best yield. But if I were able to join those two jobs together, I get a better yield. Now that's just two jobs mixed together. What if I had 3, 4, 5, 10 jobs mixed together? Well, that's what we call cart control. You would get a great yield if you mixed 10 different jobs together, but on one sheet, you might have parts for all 10 jobs, and now you maybe don't have enough room to put 10 carts around the router to unload the parts onto. So we have a feature called cart control. And the first thing you do is you tell it, hey, what is a cart? What's a cart? Well, the cart, in this case, maybe it's just one of the label fields. So any of the parts that have a label field number 1 that says cart 1, that becomes a cart. And that could be like a work order number or a job number, a customer name. It could be a room, like it just could say kitchen. And everything that says kitchen is one cart. Everything that says office is another cart. So you set up what's a cart. Then you tell the material how many jobs per cart you'd like to allow. And there's a protective open cart threshold. This is a percentage in there. So it says, hey, look, if my yield falls below 80%, then go ahead and add another job to that sheet till you get to 80%. So with that result, here you've got 4 different jobs that are represented in different colors. And there's never more than 2 on a sheet at once, except for this sheet here where I have 3 different colors. Okay, so it fell below 80% and was able to add some other cart to this until it achieved the 80%. So this allows you, and in this case, I'm just showing 2 just so it doesn't get real busy, but you could have, obviously around the machine, you may have room for 3, 4 carts, or they could consider them a pallet, right? You unload the parts, put them on a pallet. So this allows you to control your output, controlling the parts once they come off the router, and giving you a better yield and protecting your yield as well.
Hey, Kenny, I like that this cart control feature lets me efficiently manage all of these different parts, but still lets me maintain control of my yields when running multiple of these larger jobs at once. But how do I know which part gets which label on the nest? And before we get into that, we have our next poll question. Do you use custom labels to help identify parts? Yes, manually write label information on parts. Yes, using an automated labeler or label. No, no, but would like to. And we'll give everybody a little bit of time to put in their answers.
Interesting results. Thank you for answering those poll questions. You know, identifying the parts is enormous because your router can make so many parts so fast, and a lot of them look alike, right? So being able to identify the parts is critical. Making labels is one solution for it, and RouterSim includes a full labeling program built right in that allows you to customize the labels however you want. And The latest version now does both 2D and 3D barcodes. You could put logos, you got bitmaps of the part image on there. Up to 8 user label fields can be in there. And by the way, if you're using 3D solids with Inventor or SolidWorks, you could, or Solid Edge even, you could put in part properties. You can enter your label information right during the modeling process. And customizing your labels is great. You can get labels for every part in the job printed on sheet type labels right out of the RouterSim program. So all the labels for all the parts in the job printed on sheet labels or roll feed labels, and they're fully customizable in size and data that's on the labels. Another option is our very popular program called Touch and Print. And this actually runs on the router if it's PC based or a small computer near the router. It shows a picture of the nest. It shows a picture exactly what the operator sees. After the parts are cut, this is what the layout looks like on the table, and he could touch a part and print a label on demand. So that's what we call it, touch and print. He sees the part, he touches it, prints a label for it. Touches the next part, prints a label. So this is on-demand labeling. You could choose the next sheet right here. And this runs right, like I said, right there on the PC at the control or on a small computer near the control with a printer plugged into it. We also know that a lot of machines today have automatic label printing, and RouterSim can output to those machines as well. So we can connect to various machines that do label printing or inkjet printing at the router. And that's a very complex feature, but it can be added into your RouterSim software so that the machine knows where to stick the label and it does it all automatically. So we've got a couple different options, manually printed labels where you stick them on there. And by the way, you'll know where to put this label when you look at the printout that RouterSim gives you. You've got your part name on the printout, and it matches the label name and an nest ID here, and you stick the part on there. Or use the touch and print where you could see the part, touch it, print a label. And of course, the newer machines that have automatic label printing, we've got that too.
Awesome, Kenny, thanks. And just to kind of bring it home for everybody, it is important to know that certain practices in your woodshop can save you time and money. This is especially important in today's environment. Whether it is difficulty programming different machines, handling small parts, poor nest yields, or any other issue you may face, there are oftentimes solutions out there that can help you. Especially us over at CIM-TECH, we strive to make things easier in your woodshop.
Thanks, Giovanni. Let's open it up to some questions and answers.
All right, Kenny. Great job, you guys. We do have several questions that have come in. First question, what types of machines can you program to use the multi-post function?
That's a good question. Thank you for asking. The RouterSim software has been out for over 30 years, so we've got post processors for virtually any machine. We can make a post for any machine at all with whatever output that it needs. And so the answer is every machine. Any machine and every machine can output to the multi-post.
Let me just say, I'll ask you my own question, Kenny. Does it matter how old the machine is, or is there a certain age of machine where you can't do this?
That's another really good question. I don't know how many of you remember the days before USB was something called RS-232, and it was not a pretty world back then. We had to make special cables. So we can make the programs, but the challenge on older machines becomes, how do I get the programs from my CAD/CAM computer into this very old control that needs an RS-232 connection? And using DNC software, you could still do that, but that is the biggest challenge, is being able to connect to the older machine to communicate with your CAD/CAM station. So if it takes G codes, and of course before that there was even paper tape punches, and you can punch a paper tape if you want.
Thanks, Kenny. Here's another question, and we have several questions that have come in, and I'll repeat again that the folks at CIM-TECH will do their best to answer all these questions because we're not going to be able to get to them all. But here's one, Kenny. What CAD products are compatible with Router Sim?
Another good question. Thank you again for asking. Router Sim's integrated right inside of AutoCAD 2021. Our latest version, 2021, works with AutoCAD 2021 as well as 2020 and 2019. But we have older versions that work with the older AutoCADs as well. We also work integrated inside of SolidWorks, Solid Edge, and Inventor. Also, latest 3 versions, 2021, 2020, 2019 versions. We can import files from virtually any kind of CAD software as well. AutoCAD has an import feature that lets you import from anything. If you can't get it into AutoCAD, that's not mainstream
Sure.
CAD.
Yeah, that makes sense. So here's another question, Kenny. How are you handling the training of your software and these features during the pandemic?
Oh, good. Another good question. Thanks again. Well, you know, I don't like this pandemic any more than anybody else does. So over our years of integrating this software, we know that the best way to get trained and get up and running the fastest is with hands-on, on-site training. If you want the best training, that's it right there. Hands-on, we cut parts with you. Our instructor's got over 15 years experience. He's been in thousands of shops. That's the best way to do it. So if your state allows people to come in and do on-site training, we can come on-site and do it. But we've also had great success with internet training as well, because it is one-on-one using similar technology what we're using here. Go to meeting, we can share each other's screen, and we can do internet type training and get you up and running with that way as well. And that is one-on-one based training.
And I'm assuming that you guys are already very much involved in doing that right now.
Yes, absolutely.
All right. Well, thanks, Kenny. We're just about wrapping up here. I do want to let the audience know that CIM-TECH will be doing another one of these webinars later in the fall. We haven't identified the exact date yet, but pay attention to what we're doing at Woodworking Network, and we'll be sure to invite you to an upcoming CIM-TECH webinar. Like I said, we don't have our date picked, but we'll let you know about that as soon as possible. Kenny, here's Kenny's contact information, and the folks at CIM-TECH also told me that they will be participating in IWF Connect. So that's an opportunity perhaps to get even more information. A reminder again that before we log out here today, handouts are available here if you want a handout of a basic CIM-TECH brochure or this complete PowerPoint presentation. It's available there. So there's Kenny's contact information. Let me just say, great job, Kenny and Giovanni, and thanks everyone for participating today. We had more than 60% of you people participating in the polls. Just a final reminder that today's webinar has been recorded and you'll be able to access that in less than 24 hours. So I'm going to give Kenny and Giovanni an opportunity to say so long to everybody. Kenny, Giovanni.
Thank you all for attending. Thanks. Have a great day.
Thank you guys for taking the time.
Well, great. Thanks everybody for joining us, and we'll hope to connect with you again soon. Thank you.